For lesson 1's homework, we're going to go over more how to solve systems of equations graphically. So if we look at the first one, it says, solve the system of equations by graphing the equations on the given set of axes. So these are nice because they're in y equals form. So y equals 2x minus 2. So if I look here, I'm going to bring this down. I have a slope of 2 over 1, which means 2 up and 1 to the right. And I have a y-intercept of negative 2. So I'm going to start at negative 2, and I'm going to go up 2 over 1, up 2 over 1, and so on the whole way up my graph. When I get all the way to the top, then I'm going to go in reverse, down to right 1, down to left 1, the whole way, and then I will connect all of these points with a line. And now, since I know this is a system and I know we're going to be putting multiple lines on the same graph, I have to make sure that I label it. So there's my first one. My second one gives me a slope of negative 1/3, which means I'm going down 1 and right 3, and then a y-intercept of positive 5. So now I'm going to start at 1, 2, 3, 4, positive 5. And then I'm going to go down 1, right 3, down 1, right 3, down 1, right 3. Then I'll go in reverse, up 1, left 3, up 1, left 3, up 1, left 3. And then I will again connect all of these points with my line. Now make sure that you are always using a straight edge or a ruler or something like that to connect your lines. So now if we want to solve, we need to actually identify that point of intersection, which in this case is 1, 2, 3, comma 4. All right, so the point of intersection is our solution for all of these. When we look at the second one, now we have a little bit of work to do because these are not in y equals form. So I'll take the top one and I'll start by subtracting 5x from both sides. 10y equals negative 5x plus 10. I'll divide everything by 10. And I'm going to get y equals negative 1/2 x plus 1. So there's going to be my first equation. Second one is fairly simple. All we have to do is subtract the x on both sides. And we get y equals negative x plus 4. So that gives me a slope of, remember, there's really an imaginary negative 1 in front. So it's negative 1 over 1. So we're down 1, right 1. And a y-intercept of positive 4. Now I'll go back and just do that for the first one as well. Slope is negative 1/2, so we're down 1, right 2, and a y-intercept of positive 1. So if I graph that first one, start at positive 1, we're down 1, right 2, down 1, right 2, and so on and so forth throughout the whole process. We'll go in reverse. We'll go up 1, left 2. I don't really like that line, so I'll try that again here. Y equals negative 1/2 x plus 1. Now remember, you can use either the original equation or the new one for your line. It's up to you. For the next one, we'll start at positive 4, and we go down 1, right 1 the whole way. And then when we've run out of room, we're up 1 and left 1. So now, once we have both of our lines graphed here, okay, graphed and labeled, now we can identify our point of intersection, which is right here. And the coordinates to that point are 1, 2, 3, 4, 5, 6, negative 2. For the third one, is 3, 7 a solution to the system 3x plus 4y equals 20 and x equals 3y minus 18? There's a couple different ways you can do it. The non-technology way would be to plug it in and just substitute. So our 3 is our x, our 7 is our y. So 3 times 3 plus 4 times 7 equals 20. So this is for our 3x plus 4y equals 20. 3 times 3 is 9, plus 4 times 7 is 28. 28 plus 9 gives us 37, and 37 does not equal 20. Now, I'm just going to plug it in for the other one just to verify and make sure that I'm not missing anything. So when I do that, I get 3 equals 3 times 7 minus 18. 3 times 7 is 21. 21 minus 18 is 3. And you get 3 equals 3. So it works for one, but not the other. So therefore, no, because it is not a solution to both equations. Remember, in order for it to be a solution to a system, it must be true for both of them. Now, the other way to do this would be to plug it into your calculator. The only thing is, they would both have to be put into y equals form. So that's a little bit more on the complicated side here. So we're going to leave that one just to we're going to leave this one just as doing it by substitution. And for the last one, Central High School had 5 members on their swim team in 2000. Over the next several years, the team increased by an average of 10 members per year. The same school had 35 members in their chorus in 2010. The chorus saw an increase of 5 members per year. Write a system of equations to model this situation, where x is the number of years since 2010. All right, so let's look here. We've got to write 2 equations. One for the swim team. Well, what do we know? We know that the total number of people was, well, they started with 5, and every year they increased by an average of 10 members. So 10 members per year times the number of years, plus the 5 people that they started with. The chorus, on the other hand, again, we're still going to use y equals because it's still going to be the total. Y equals, well, they saw an increase of 5 members per year, but they started with 35 people. So now what we want to do is we want to use a table to solve this system of equations, and we want to explain the meaning of the solution. So I'm going to make the swim team y1, and I'm going to make the chorus y2. And what I'm going to do now is I'm going to make a table based on what I would see in the calculator. So if we start at 0, we already know those. Those are our y-intercepts 5 and 35. So we're going to start at 1. And I'm just going to make a list here for a while to see what I get. So when I plug in a 1, and again, you can just copy this from your calculator. So it should be 15 and 40. Then it should be 25 and 45. Then we're going to be 35 and 50. 45 and 55. Then we're going to be 55 and 60. And then we will be 65 and 65. So we found the solution to this system. Now remember, x is the number of years and y is the number of people. So if we want to explain this, after, or actually not even after, the best way to put it would be in year 6, which in other words is 2016, since it started in 2010, both groups will have 65 members. So what our system's basically helping us find here is it's helping us find the time when these two groups are going to have the same number of people. And that happens after when x is 6, so 6 years after 2010, which is 2016, and they're both going to have 65 members.